Hello Year 10. So today's lesson is going to be on vectors, and you can follow along on pages 410 to 411 in the book on Caboodle. So just following on from our previous lesson, here's the definitions that we had. First of all, a vector has two properties, and we know how long it is, so basically the distance from here, how long it is there, and the direction, which is signified by an arrow, so A going positively that way. And if you remember from last time, if vectors are parallel but going in opposite directions, then it's a negative vector. So A and negative A. So those are things from last lesson, just a quick recap there. Okay, so here's a little question for you. If vector A is 4, 0, so going along 4 and down none, so 4, 0, and B is 0, 3, going from there to there, can you make the following vectors using vectors parallel to A and B? So I'm looking for vectors 8, 6, negative 12, 3, and 2, negative 9. Okay, I'd like to pause the video and see if we can have a go at working out what vectors they could be, and then replay, and we'll go on to the answers then. Okay, so you've had a go. We could find a vector 8, 6 by doing 2 A's and 2 B's, as you can see there. And then the vector 2A and 2B goes from this point to this one, 2 A's and 2 B's. To get negative 12, we need to do negative 3 A's and add a B. Negative 12, 3. So that's negative 3A, add B. And the next one, to get 2, negative 9, since A is 4, 0, we needed half of A to get the 2, and then negative 3B, so going in the opposite direction for B, negative 3B giving half A minus 3B. So that's the vector there, representing half A, subtract 3B. Which just shows that we can have fractions of vectors as well. Okay, so moving on to today's lesson. Okay, so again, I'd just like to take time to have a look at this question. So what I've drawn is an X and Y axis, and then we can see going from 0 to 10 and 0 to 7, and multiple points A, B, C, D, E, F, G. And what we're going to do is going to do a similar task at that beginning, just to talk you through exactly how things work. So if you'd like to draw that out or just follow along, make notes if possible, that'd be great. So we've got two vectors popped up there, as you can see, and a vector A and a vector B. So we've got A to B is A to C is B. And notice the arrows above the capital letters, just like we had previously. So an arrow telling you which direction it's going, and I like to use this twiddles under my A, or you can just use a straight line to show it's a vector. So there's A there, going from A to B, and then A to C, going from A to C, the arrow in that direction. What we're going to work out is A to F, so from A to F, how we go from there to there, and A to D, so how we go from here to here, then C to E, and then B to G. Okay, if you'd like to have a go yourself, that's fine, but I'm just going to tell you the answers anyway, so going through them. So, A to F. From A to F, we need to go across 4 there and up 6, so that's 2 A's, add 2 B's. From A to D, it's quite simple. Look, we just go across here, we've got 2, 4, 6 there, so we've got 3 A's as we go across. From C to E, it's actually the same vector look as A to D, so it's the same answer, 3A there. Then B to G is slightly more complicated because of the numbers of A's we need. We only need 3.5 A's to go to there, and we only need 2/3 of B to take us up to there. So 3.5 A's add 2/3 of B takes us from B to G. Obviously we could draw those vectors in now and put arrows on them to represent them. Okay. Over to you now. You can try page 411, 19.4a. Pause the video and try question 3. This is question 3. Just going to tell you a little bit about it. So it says O to P is vector P, so that is vector P just there, and O to Q is Q just there. So we've got a very similar situation to the previous question. It would like O to G in terms of P, and then O to L and so on. And there's more questions in the book So if you ever go at those questions now and then come back to the video. Alright, so moving on. So remember from last time we did a parallelogram example. We talked about the vector d to a being a, the vector a to b being b, and we did what is the vector c to b. C to b is parallel to vector d to a, going in the same direction, so it's the same vector. And then c to d is parallel a to b, but going in the opposite direction, so it was negative b. The questions today to think about is what is vector db and what is vector ca. So I want to know how we get from d to b and how we get from c to a. So those are them drawn on there. To get from d to b, we need to go along vector a and along vector b. So that's a add b. Just there, a add b. Vector c to d, I mean, you've got a choice. We just so c to a. And we need to go maybe from C to B, then B to A. If we go from C to B, we know that one was vector A, and then B to A would go the wrong way down the vector, so that would be a negative B. So we'd have A subtract B, or we can go from C to D and then D to A. C to D we knew was negative B, and d to a is a. So just take some time to think about that, and then we're going to go on to how we label ourselves and how we work through questions. So if you'd like to draw this in your notes, that'd be really useful for yourself. So we've got OABC is a rectangle, OABC. Vector O to A is A, so this is A in this direction. O to C is C. What is vector O to B? So just going to label the things. First of all, vector A, there labelled, O to A with the direction that way, little a with the twiddles underneath. O to C, going this direction with C next to it, and the one I'm focusing on is O to B. So to get from O to B, I need to go down from O to C, then C to B, or go from O to A to B. And we know C to B as a vector is parallel to O to A, so it's identical. It is A, it's going in the same direction, so O to B will be A add C, or C add A as it's written there. You just go down the different vectors and work out which ones it is. So now again, you're going to pause the video and try questions 1 and 2, and then we'll come back and finish off. Okay, so coming back in, an example now from a trapezium. OABC is a trapezium. The parallel sides C to B and O to A are such that C to B is 3 lots of O to A. So in this picture here, can you see that C is 3 lots of O to A. So O to A is A, C is 3A, because A times 3 is 3A. O to C is B, so this vector is B just there. We're going to write the vector from A to B in terms of A and B. So to go from A to B, this is the line we want, but there's no arrows on it, so it's useful to go back through around the picture until you get to where you need to be. And that there would be the wrong direction. So a negative A, positive B, positive 3A, so a total of 2 A's and a B. So as you can see, the working out is here to go from A to B. They said you need to go from A to O, O to C, C to B, because that's where the arrows are. A to O is negative A, because AO is the same length as OA but in the opposite direction. A to B then would be, as I said before, negative A plus B plus 3A, so 2A add B. Okay, so that's pretty much the end. So now try questions 1, 2 and 3 if you didn't pause the video, then complete questions 5 and 6. Okay, good luck.